All right, day 16. Uh, Hopefully it goes pretty well. Um, let's try it. So each came in each open water to receive a transmission from the else back in the chip. The transmission was sent using bits, a method of packing numeric expressions into a binary sequence. Your computer has saved the transmission in hexadecimal, your puzzle input. First step in decoding the message is the hexadecimal representation in binary. Each character of hexadecimal corresponds to 4 bits of binary data. Okay, the bits transmission contains a single packet. Its outermost layer, which itself contains many other packets. Successful representation of the packet might include a few extra zeros at the end. These are not part of the transmission and should be ignored. Every packet begins with a standard header. The first 3 bits encode the packet version, and the next 3 bits encode the packet ID. These two values are all numbers encoded are represented as binary with the most significant bit first. For example, a version binary sequence 100, packets type ID 4, percent total value, encode a single binary number, do this by this, Jesus, this is gonna be long. All right, this is like extremely elaborate. Let me well, let's start by doing the decoding. Let's just write that. Actually, you know what? Def hex to bin hex car, which is a string, goes to a string. No. Boy, I don't even know what that is. But it's frightening. Let's try the other solutions. It's not giving me any other solutions. All right, I don't have the slightest idea. Um, well, actually, let's try his idea. Int a comma 16. And now let's do bin of this. And finally, let's try this to a binary string of length 4. Come on, you had it. What you gave me was good. Come on, why are you not? I don't even know what zfill is. Let's play with this. What did I call it? Hex car equals f. Okay, and hex car equals 9. Hex car equals 4. Okay, that seems to work. 0100, 1001. Yep. Okay, so that seems to work. Bits transmission contains a single packet at its outermost layer, which itself contains many other packets. Hexadecimal representation of this packet might encode a few extra zeros bits at the end. These are not part of the transmission and should be ignored. Every packet begins with a standard header. The first 3 bits, and let's make this hex card to bin, and def hex to bin hex string. So that's probably right. And assert that hex to bin of, let's just write a test. And notice that I'm really avoiding getting into the problem because it looks like a real pain in the ass. Equals that. So let's just run this. Okay, good. So now we can get to the below. Okay. Every packet, the single packet, which itself contains many other packets, hexadecimal representation of this packet might include a few extra 0 bits at the end. These are not part of the transmission and should be ignored. The packet begins with a standard header. The first 3 bits encode the packet version, and the next 3 bits encode the packet type ID. These first 2 values are numbers. All numbers encoded in any packet are represented as binary with the most significant bit first. Okay, so let's make a class for the packet, and let's init it from bytes, which is a string. So let us go back here and say the first 3 bits encode the version. Okay, and let me just Python int 0108. Does that work? No, that doesn't work. Because it's binary. That's why. Okay, so first 3 bits encode the version, and the next 3 bits encode the packet type ID. Okay, so let's say version equals int bytes 0 to 3, comma 2, self.type ID equals int bytes 3 to 6, comma 2. That's good. What? Right, because those are, I wrote it in leet speak. And then I think we'll probably want to get rid of those. Bytes equals byte 6, right? That's smart. Numbers, all numbers encoded in any packet are represented as binary with most of it. For example, version encoded. Okay. Packets with type ID 4 represent a literal value. Literal value packets encode a single binary number. To do this, a binary number is padded with leading zeros until its length is a multiple of 4 bits, and then it is broken into a group of 4 bits. Each group is prefixed by 1 bit except the last group, which is prefixed by 0 bit. These groups of 5 bits immediately follow the packet header. For example, hexadecimal string this becomes that. 3 bits labeled V are the packet version 6. The 3 bits labeled T are the packet type, which means the packet is a literal value. The 5 bits labeled A start with a 1, not the last group, keep reading, and contain the first 4 bits of the numbers. Okay, and the 5 bits labeled 1 start with a 1. The 5 bits labeled C start with a 0, last group, end of packet, and contain the last 4 bits of the number. 3 bits are hexadecimal. So this represents a literal value with binary representation, that, which is that. Every other type of packet represents an operator that performs. Right now they're focused on parsing the hierarchy of sub-packets. Okay. An operator packet contains one or more packets. To indicate which subsequent binary data represents sub-packets, an operator packet can use one of 2 modes indicated by the bit immediately after the packet header. It's called the length type ID. All right. If self dot, and was that type ID equals 4, type ID equals 4, pass, else, pass. Okay, so this is a literal value. Otherwise, it's an operator. So let's go back and read about operators. An operator packet can use one of 2 modes indicated by the bit immediately after the packet header. If the length type ID is 0, the next 15 bits are a number that represents the total length in bits of sub-packets contained by this packet. If the length type ID is 1, the next 11 bits are a number that represents the number of sub-packets immediately contained by this packet. Finally, after the length type ID bit and the 15-bit or 11-bit field, the subpackets appear. For example, here's an operator packet with length type ID 0 that contains 2 subpackets. 3 bits labeled this. Okay, the bit labeled I is the length type ID, which indicates the length of 15-bit number representing the number of bits in the subpackets. 15 bits that contain the length of the subpackets in bits 27. The 11 bits labeled A contain the first subpacket, and the 16 bits after reading 11. And so how do we know that here's an operator packet with 1 subpackets. The length of the limit number is the number of subpackets, 11 bits. Okay. In 3 complete subpackets, number of subpackets indicate. For now, parse the hierarchy of packets throughout the transmission and add up all the version numbers. Okay, so subpackets, the length type of the next number contains the total length and bits of the subpackets. If the length type is 1, so the next bits number that represents the number of subpackets. Okay, so let me see if I understand this. Private length type 0 that contains 2 subpackets. I is the length type ID. The 11 bits labeled A contain the first subpacket, a literal value representing the number 10. Okay, I think I get it now. No, maybe I don't get it. And then here I have 3 sub packets. So here is a total length in bits. Okay, so the question is, how do I know where to stop? And I know where to stop because I start parsing from A, and all right, you're going to enjoy today's easy. The spec is just long. Sorry, this has got to be boring watching me start this. But literal value packets encode a single binary number to use binary path that zeros in length and its broken into groups. Each group is prefixed by a 1 bit, except the last group, which is prefixed by 0 bit. Okay, so that's okay, so that I get. I can write that. Every other packet represents an operator that performs some calculation on some packets. Right now, this specific operation is important. Focus on parsing the hierarchy. Operator packet contains 1 or more packets to indicate which subsequent binary data represents its subpackets. An operator packet can use one of two modes indicated by the bit. If the length type ID is 0, the next 15 bits are a number that represents the total length. If length is B, then the number that represents the number of subpackets immediately contained. Finally, after the length type ID bit and the 15-bit or 11-bit field, the subpackets appear. All right. No, that's not going to work. Well, let's just start writing out the code. And what I need to do is, no, I need to read this again. Hold on. Of course, this is one day I start with not very much battery on my laptop, hoping it would be fast. Operator packet, which contains an operator packet, which contains an operator packet, which contains a literal value. This packet has a version sum of 16. Represents an operator packet which contains two subpackets. Each subpacket is an operator packet that contains two literal values. This packet has a version sum of 12. The part that I'm really struggling with is how do I know how far to go? Let me try a different approach. And it's going to have a version, which is an int, and it's going to have a type ID, which is going to int, and it is going to have sub packets, which is a list of packets. And what I can do is say static method parse bytes string goes to a packet, and let's say start int equals 0 goes to a packet, and then I actually don't need to do it that way. Very interesting. Except this was start plus 3, start plus 3, start plus 6, and then let's say start plus equals 6. And now if version equals 4, so this is a literal. Okay. Binary number is pad with linear zeros and its length multiple of 4 bits, then is broken into groups of 4 bits. Each group is prefixed by a 1 bit, except the last group, which is prefixed by a 0 bit. Yeah, I'm still not quite understanding something about this. 3 bits labeled V are the packet version, translates to the packet type ID, which is a literal value. And then I keep reading until it's done. The question is, how do I return where I left off? And so maybe what I need to do is, boy, I hate doing this, but it'll be a tuple of a packet and an int, where the int is the new start. Okay, and so the 3 bits labeled start with a 1. Digits equals this, while bytes start equals 1, right? Then I read it in the first 4 bits of the number. Digits dot append bytes start plus 1 start plus 5, and start plus equals 5. And now we have the last byte. And it's 5 bits labeled CSR with 0 last group in the packet contain the last 4 bits of the number 101. Okay, and so on and so forth. So let's do this. While true, that and we have the last byte, and so we have to basically just do it again. Digits dot append byte start plus 1 start plus 5 start plus equals 5, and represents a literal value with binary representation. And so now we want to packet equals packet version type. Did I mess this up? It should be type ID, not version. If type ID equals 4, packet version type ID, and let's say value equals int of join the digits 2. And let's say value equals value, and return packet comma start. Okay, so what doesn't it like about this? Expected no arguments to packet. Why? Because I forgot the data class. Okay, so I think that's right. Else it's an operator, and what I have is immediately after the head of the length type ID. So length type ID equals bytes start plus equals 1, and if length type ID equals 0, pass. If length type ID equals 1, pass. Else. Okay. I don't know how I need to do that other than binary. Length type ID is 0, then the next 15 digits are a number that represents the total length in bits. Okay. So let's say total length in bits equals bytes start to start plus 15, and we'll say int that comma 2 start plus equals 15. Otherwise, if the length ID equals 1, number of subpackets is the next 11 bits, and sp equals int byte start plus 11 comma 2 start plus equals 11, nsp equals tlib equals none, so that way I've got both of those. Okay, and let me do one thing. Man. For all zeros. If all bytes I equals 0 for I in range, start len bytes. I don't know why it's giving me so much junk. I'm just going to return none. So that's just how I know that. Anyway, this is like a huge mess. So so total length in bytes is that. So that means that end equals start plus tlib. Okay, and so subpackets equals this. While true, subpacket start equals parse byte starts. I don't think if subpacket is none, break. Okay, that's good. And what about if subpacket is none or start if subpacket is none, break. Subpackets append subpacket. If start is bigger than end, break. Actually, subpacket shouldn't be able to be none. Well, anyway. and then return packet comma start. That seems right. And now if length type ID equals 1, start plus equals 11, and sub packets equals this, and now while len sub packets is less than NSP, sub packet start equals parse bytes comma start. Sub packets, it's append sub packet. That seems right, and that seems right. Okay, so the question is, did I do the right thing? And almost certainly I didn't. So let me run day16.py. Okay, so already I have an error. Perfect. And now let's say hx equals this, and I want to do parse hex to bin of hx. Packet version 6 type id equals 421. Okay. So let us try another one. Let's see if this works. My guess is it won't, but maybe I'll get lucky. Version 1 type ID sub packets, version 6 value 10 op none, version 2 value 20 op none. Hey, what do you know? Alright, so now let us try this one. Notice that I don't actually have a unit test. I'm just punching these things into this. Version 7 type ID 3, sub packets, 3 sub packets, literal value containing value 1, a literal value containing the number 2, a literal value containing the number 3. Add up all the version numbers, okay? Alright. Add up all version numbers. And let's do hex string, which is a string, and goes to int. And so, yes, yes. Sum of versions self goes to int. Return self.version plus sum of packet.sum of versions for packet and self.subpackets. Okay. And yep, and then return packet.sum of versions. Okay, so now let us write a few unit tests. So that should be 16. Okay, so let's try that one. Okay, and this one has 12. this one has 23. I'm still worried that I screwed something up that's going to go badly on the actual one. Add up all version numbers. And then finally, 31. Search, add up all version numbers. This equals 31. Add up, add version numbers. Okay, so let's try all these. So that worked. Okay. To code the structure, what do you get if you add up the version numbers and all packets? Okay. So here, I'm just going to hard code this. Okay. Yep. Nope. Print packet dot sum of versions. Okay. Let's try it. 989. That is the right answer. Okay. Now that you have the structure of transition code, you can calculate the value of the expression represents. Literal values type ID equals 1 represent a single number described above. Any type IDs are more interesting. Sum, product, minimum, maximum, greater than, less than, or equal to. Using these rules, you can now find the value. Okay. Running out of battery is the real problem here. But we'll see if I can figure that out. I think I can do this part pretty fast. Def evaluate self goes to int. Let's put here into it. Actually, I won't even do that. If self.type ID equals 0, sum packet, their value is the sum of the value of their sub packets. Good. Okay. Elif self type ID equals 1. Product packets. Oh, come on. Does this version of Python have product in it? Dang it. I hate reduce. So return reduce packet value packet self. Fine, you win. Elif self reduce is not here. From functools import reduce. I'm sort of hoping that that's right. Minimum packet. Turn minimum device. Okay. Yeah. Oh, that's smart. Okay. Sure. Can you do it? Nope, that's not right. Type 84 we already said is literal value. So return self.value, good. Otherwise, if type ID is 5, then greater than packet. Good guess. Greater than packet. Value is 1 if value is first sub packet is second. Otherwise, value is 0 if it's always have exactly 2 sub packets. Cert len of self sub packets equals 2. Elif self dot type ID equals 6. Less than packet. Good guess again. Less than packet. Cert, yep. And then return 1 if 0 is less than that. Okay. If self dot type ID equals 7, equal to packet. Perfect. All right. Good job. And then otherwise, there you go. Raise value error. Okay. And so now, let us write some unit tests again. and let me actually write a helper function, which is def evaluate hex string, which is a string, and it goes to an int. Come on, you can do it. You can do it. Thank you. Okay, so it knew what to do. It even knew to use my leet-speak variable name for bytes, which is good. And return packet.evaluate. Okay, and so now I want to assert, I don't know what that is, that this equals 3. Let me just copy and paste this a few times. Actually, a few more times. $54. 7. 9. 1. You may think it's excessive of me to do all these unit tests, but if I got one of them wrong, this will save me a lot of time versus not doing them, because it'll help me figure out exactly what is not right. This one is 0. And assert that evaluate of that produces 1. All right, let's run all these. All right, they all pass. Perfect. So now I want to evaluate so it gives me this large number. Let us see if that is correct. If it's not, I don't really know what to do. Okay, that is the right answer, 1 gold star. Okay, so I spent a long time getting really hung up on how do I parse these things. And the trick that I needed was that this parsing function needs to return both a packet as well as the position where I left off. And I don't know if this part was even necessary, but whatever. And then it was a matter of reading the instructions, following the instructions, and just being careful about, total length of bytes is this, so I know exactly where I want to end, and just doing this recursively until I end. And then otherwise I have the number of subpackets, and doing that. So it all worked. Copilot wrote a lot of the code for us, which is nice. But yeah, that was actually a pain, and I hate writing parsers off the top of my head. Not the most fun thing, but we got it done. I still have 15% battery, yeah, so let's see. Today's easy, just the spec is long. Okay, well, I'm not sure I would call this easy, but yeah, the spec is definitely long. Okay, this is Copilot updated by hand, given an enum for type ID. Copilot wrote the whole eval in one go correctly. Yeah, I mean, that makes sense. It seemed to have written most of mine correctly just with the comments, and so on and so forth. So, yeah, anyway, got it done. So, thanks for watching, and hopefully tomorrow, I bet tomorrow they'll make us reuse this. So, in fact, they'll probably make us reuse this for the next 9 days. So that's the way things seem to go. Anyway, thanks for watching. I'm glad I figured it out. I was worried about it for a minute.